discuss about Moore FSM. So FSM stands for finite state machines, and like it is called as it is also called as sequence detector. So a sequence detector is a sequential state machine that takes input of bits and generates an output one wherever the target sequence has been detected. Like we have taken a bit input bit stream like 10 bit 10 bit input, and we want to detect how many times sequence 101 we can take. So like how many times 101 is there in that sequence. So wherever the sequence 101 is found, then there the output of our sequence detector becomes high. So there are two types of sequence detectors, like one is Moore sequence detector and other is millisequence detector. So in Moore sequence detector, we consider only our output considers only present state. It is not dependent on the input X. So like we will see in further slide. Okay. So Moore sequence, every sequence detector, like maybe it is Milli or Moore, it is of two types, like overlapping sequence detector and non-overlapping sequence detectors. So in this video, we will see about overlapping sequence detector. So, like we want to detect 1011 sequence from the input. So how to proceed with this? How we can detect 1011? Like we will take our state like S0, S1, S2, and S3 and S4. Okay. Like initial input is 0. So when input is 0, so our sequence is starting from 1 here we can see. So we will remain on the same state. We will not proceed further. So, but when our input is 1, then we will move to S1. Like for S1, when input is 0, because 0 is in our sequence. So when input is 0, we will move to S2. And when input is 1, we will remain on S1. In both cases, like the /1 is output. In both cases, the output will be 0 because our output will be 1 when the whole sequence is detected. So further moving to S2, when S2 is 1, then our sequence is then we will get 101. So we will move to S3, but when S2 equal to 0, so what will be the sequence? Like it will become 10, 1010, sorry, 100. So 00, it will like this initial condition. So we will go to initial one, S0. Okay. After that, okay, yeah. So when S3 is 1, then we will go to S4 and our output becomes 1 because we will complete the whole sequence 1011. Okay, but when S4 is uh, when S4 is 0, then we will then we will go to 10 case because it will become same 1010. So we will go to S2. Okay. And at last case, when S4 is 1, so it will become 1011. So our sequence will start again from there. So we will go to S1. Okay. So this is the simply state table. Like here is a current state. What we are going with current state S0, S0, 1, 2, 3, 4. Here is the next state for X equal to 0. Here is the next state for S equal to 1. From this diagram, we made this table. So clearly like S0 here, you can see S0, the next state for X equal to 0 is 0, the next state for X equal to 0 is 0, and for X equal to 1 is S1. So like this, you can make this table. And now we will implement this by using VHDL code. So first of all, we will like in VHDL we include the IEEE library. So first of all, we included the standard IEEE library. After that, we created an entity and we declared X1 and clock as an input port and Z1 is in our output port. And after that, we will declare the architecture. So here we consider the type variable. So state type is like we have 5 state S0 to S4. So S0, S1, S2, S3, S4. We declared our these are state type, and here we consider two signals, present state and next state, which are of state type. So now we will begin and process present state and x1. So we'll process this present state and x1, and simply here we will write the case for present state, and when s0 equal to when s0, then z1 equal to 0, because uh, our Z1 will be detected when it will be on S4 state. For S1, S2, S3, S4, all S3 state, our Z1 will be equal to 0. So S0, Z1, 0. So like this, we can write this. If X1, this is our input bit. If X1 is equal to 0, then next state equal to S0. And if X1 is not equal to 0, then our next state equal to S1. So from this table, like you can see, when our current state is S0, then our for X equal to 0, the next state is S0, and for the current X equal to 1, the next state is S1. Like that, we implemented this table by using VHDL code, nothing more than that. So simply we write for S0 state here, like above we write for S1 state. Here also the output will be 0, and after that we will write for S2 state, and after that we will write for S3 state. Similarly, we will write for S4 state. But here the output bit becomes 1, because at S4 state, like you will see in this diagram, uh, our S4 the output of S4 equal to 1. So the next state for S4 we have written that, and after that we will end the case statement, like we will end that case and we'll end the process. And now we will declare the change of clock when where this operation will occur. So it will be when the clock tick event and clock equal to 1, then the present state implies to next state. So this event occur when the clock equal to on the rising edge of clock. So after that we will end the behavioral architecture, and this is the RTL schematic for Moore machine. So here you can see clock and X1 and Z1. So these two are inputs, and this is this is output. So, like this is an output waveform for this input. Like you can see whenever the sequence is detected, then our bits is going high. So like you see in this case, for first time our sequence will be detected here 1011. Okay, after that our sequence second time is detected here 1011, and like this this is an overlapping case. So what happens to overlapping case, we like this sequence is detected here, but here we also getting the same sequence, And so we will consider this one from previous sequence, and it will detect here also. So how many times the sequence is detected in this bit string? So it is 3 times. So you can see here 1, 2, 3. 3 times our output is going high for this input sequence. So that's all for this video. So in this next video, we will see for non-overlapping case. What will happen? Like I will give you a brief summary for non-overlapping case in this video also. So what will happen for that same input in non-overlapping case? So it will detect only one this sequence and second one this sequence. It will not detect further sequence because it will not consider this one for detect this sequence. Okay, so we will see the rest of things in next video. Thank you.